Now we go for working rules for differentiation. We already studied in 11th standard. So we take two functions, let fx and gx be two functions. The first one, that's the addition rule, d by dx of fx plus gx, that is equals to derivative of the first function plus derivative of the second function. Second rule, that's for subtraction, so you can write minus here. The next one, if you have constant k with the function, then constant will be outside and just differentiation of function, where k is some constant. We know this. Third one, that's a product rule, which is very important, d by dx of fx into gx. So we have product of two functions. So what is that product rule? You know, one function as it is, derivative of the other one. So here fx as it is, derivative of gx. Now gx as it is and derivative of the fx. We know this. This is the product rule. This is called product rule. For example, if I want to get the derivative of, let's write sin x into x square. So product of two functions. So we keep, for example, sin x as it is, d by dx of x square, plus now x square as it is and the derivative of sin x. This is what we call the product rule. This is as it is here, differentiation of sin x square, always plus sign between these two. Now x square you are going to differentiate here, so x square as it is and derivative of the sin x. So sin x as it is, differentiation of x square, now you know 2x, x square as it is, derivative of sin x, you know cos x. If you want, you can just take x outside, so 2 into sin x plus x into cos x. So this is the derivative. This way we use the product rule. Such things you did in 11th. This is just recap of what you did earlier. Fourth rule, that's called division rule. So it is d by dx of division of two functions fx upon gx. So what is division rule? You know, square of the denominator function. Then here gx as it is, derivative of the numerator function, that is d by dx of fx. You had always minus sign. In product rule you had plus sign, remember. Now interchange these two, fx into d by dx of gx. Your order is important, that first differentiation of fx should be done, remember. Your order is not important. You can write this term first. That's not important because you have plus sign. Here you have minus sign, remember. Your gx should not be 0. So this is called division rule for division of two functions. One simple example just to remind you, d by dx of, suppose I have, let me write x upon 10x, division of two functions. What is the division rule? Square the denominator function, so 10 square. Then 10x as it is here. Differentiation of x with respect to x, that is 1, you know. Minus now x as it is here, and differentiation of 10, which is x square, you know derivative of 10 is x square. So this is your answer, 10x minus x into x square upon 10 square. This is how we use division rule. You know it from 11th. So these are the 4 standard working rules. Addition rule, constant you can take outside, product rule and division rule we use effectively here, remember, in 12th also. Okay. So we go for one more example. just to clarify the concept of division rule. D by dx of 2 raised to x upon sine x. We use division rule. What is the division rule? Square the denominator function. Sine square. Derivative is not there, remember. Denominator function as it is. D by dx of numerator function. पहले न्यूमरेटर फंक्शन का डेरिवेटिव होगा, नीचे से जो ऊपर जाएगा वो एज इट इज रहेगा. Always minus sign here. Now 2 raised to x as it is into d by dx of sine x. This is what we call the division rule. A purely used division rule, remember here. Now sine square as it is. This sine x as it is. Differentiation of 2 raised to x. You know 2 raised to x into log 2. We did it. I already mentioned in the standard forms. 2 raised to x as it is. What's the derivative of sine x? Cos x. 2 raised to x as it is. You are going to differentiate sine, which is cosine. Here sine x as it is. You are going to differentiate 2 raised to x. What is derivative of 2 raised to x? That is 2 raised to x into log 2. So differentiation is over here. If you want, you can take just 2 raised to x common. So sine x into log 2 to the base e minus cosine x upon sine square. This is the derivative. I'll take one more example. Let's see. For example, we want d by dx of, let me write this, x cube plus 2x plus root x plus, let me write log x into cot x. So there are 4 terms. Remember 1, 2, 3 and 4. This is a standard function, you know, derivative. This is also standard function. This is also standard function. But here you need to use product rule, because in the 4th term you have product of 2 functions, remember. So I'll write directly. You know what is derivative of x cube? 3x square. What about this 2x? 2 as it is, because it is a constant. What's the derivative of x with respect to x1? We did it in 11th, and in the beginning also I mentioned derivative of root x. It is 1 upon 2 root x. You know it. I repeat, what's the derivative of x cube? 3x square. Derivative of 2x, 2 being constant as it is, derivative of x with respect to x1. What is derivative of root x? 1 upon 2 root x. Here we use the product rule, because this is a product of 2 functions. Now what is the product rule? One function as it is. So here log x as it is. Derivative of cot. What is derivative of cot? Minus cos x square. Plus, now cot x as it is. And what's the derivative of log x, which is 1 upon x. Remember these 2 terms, these and this, are because of this single term by product rule. Log x as it is, derivative of cot minus cos x square. Now cot x as it is, and derivative of log x is 1 upon x. So finally, I'll just rewrite 3x square plus 2x plus 1 upon 2 root x, minus will come out. So it is log x into cos x square plus cot x by x. This is what the final derivative. This way we can use, we know it from 11th standard. One more example. Let's try d by dx of, for example, we have, I'll take division as well as product both. So for example, I have, let's take sec x into, let me write e raised to x, plus, I'll take the division of 2 functions here. Let me write, for example, here 2 raised to x upon, let's write x square. So there are 2 terms. One is this, the other one is this. Okay. Here we use product rule. Here I'll use division rule. Without division rule also you can do, but I just want to emphasize on division rule. So I'll write like this, d by dx of sec x into e raised to x, derivative of the first function plus derivative of the second function, 2 raised to x upon x square. Now differentiation, here product rule. So sec x as it is. What is derivative of e raised to x? You know it is e raised to x plus, now e raised to x as it is, derivative of sec x, you know it is sec x into tan x. I repeat this part, these two terms are because of this, sec x as it is, differentiation of e raised to x is e raised to x. Now e raised to x as it is, derivative of sec x. What is that? Sec x into tan x. This is because of product rule, remember. Plus now here I'll use division rule. Without division rule it can be done. You can write raised to minus 2 and you can use product rule, remember, like this. And you can use product rule. But I just want to emphasize on division rule, so I'm doing this. Answer will be same whether I use product rule here or division rule here. So square of denominator function, square of x square, which is x raised to 4. X raised to 4 here, remember. So square of denominator function, which is x raised to 4. Now x square as it is here. What is derivative of 2 raised to x? 2 raised to x into log 2 minus now 2 raised to x as it is. And what's the derivative of x square, which is 2x? I repeat this, square of this, which is x square whole square. Now x square as it is, differentiation of 2 raised to x, which is 2 raised to x into log 2. Now here 2 minus sign, 2 raised to x as it is, and derivative of x square, which is 2x. This is division rule. If you want to just simplify from first two terms, you can find sec x into e raised to x common. So 1 plus tan x plus you can take 2 raised to x common and 1 x will get cancelled, so that way you can simplify. So this is a final, take x common, it will get with x raised to 4, so you are left with x cube. From numerator you can take 2 raised to x common. That's just simplification. Differentiation is up to this, remember, product rule and division rule. This is from 11th standard, just to recap. Now we go for next point, which is called chain rule. So next we go for derivative of composite functions. Composite means combination of 2 or more functions, and that's known as your chain rule. Now what is that? Let's understand. For example, here let me write like this. You know derivative of x cube. What is that? 3x square, that we know. But now in place of this, suppose I may have 4x plus 1 the whole cube. Now this is not a single function, this is a composition of two functions. One is 4x plus 1 and the other one is x cube. So how will find the derivative? That is the question. This is called composite function here, remember. So what we'll do, we imagine this bracket as x. Just we imagine this bracket as x. So it looks like x cube. Now what is the derivative of x cube? You know 3. We are not going to write, we consider this as x. So 4x plus 1 the whole square. What we did here? We imagine this bracket as x here. So this looks like x cube. What is derivative of x cube? You know it is 3x square. You are not going to write x, remember, you are going to write the same function. So it is 3x square into, the chain rule says that you differentiate that considered function. Which one you had imagined as x? This one. So into derivative of 4x plus 1. This is called chain rule. So finally you will get the 3 into 4x plus 1 the whole square. Now how do we differentiate? That you know from 11th. Derivative of constant is 0. 4 being constant as it is, derivative of x is 1. So 4 into 1 plus 0. It is just 4, you know. So 4 into 3, 12, 4x plus 1 the whole square. This is differentiation of which function? 4x cube. Okay, I'll take one more. Let's take, suppose you know derivative of sine x. What's the derivative of sine x cos x? This is our standard function. This was also standard function, but I may have sine of, let me write x square plus 1 like this. So what I'll do, just compare with this one. You know derivative of sine x, so I'll imagine this bracket as x. This bracket is x for us, remember. Just to imagine this bracket as x. So this looks like now sine x. You know derivative of sine x. What's the derivative of sine x? That's a cos x. So cos, you copy this bracket, which is x square plus 1. I've copied this bracket, remember, into d by dx of consider function. Which function? X square plus 1. So final answer is cosine of x square plus 1 into derivative of this portion. What's the derivative of 1? 0. What's the derivative of x square? 2x. So this is your answer. This is derivative of sine of x square. Right? Another way of explaining same thing is like this. There are how many functions? 2 functions. One is sine and the other one is x square. So first to write derivative of sine, which is cos, keeping this as it is, into derivative of x square plus 1. What is that? 2x. But sometimes this become difficult, so we need to compare with the standard function only. One more, I may have like this, sine of, let me write 4x. So how we'll do here? You imagine this as x. What's the derivative of sine x? Cos x. We are not going to write x, remember. We are going to copy that function only into derivative of that considered, that is d by dx of 4x. This is called chain rule. Chain rule says that into, always you write the derivative of the considered function. Now cosine 4x as it is, you know what's the derivative of 4x? 4 being constant as it is, what's the derivative of x with respect to x, which is 4. Here 1, so final answer is this, 4 into cos 4x. Suppose I may have like this, sine of 10x. So now you must have realized this is a composition of how many functions? 2 functions. I'll imagine this as x. So this looks like sine x. What's the derivative of sine x? You know cos x. So cosine of 10x into derivative of d by dx of 10x. So this one as it is, cos of 10x into derivative of consider function. Which function you have considered as x? 10x. So into derivative of 10x, which is x square. So this is your answer. Right? So in composition, after some standard function, you imagine these as x. You know sine x, you know sine x, you know sine x. Remember, this is sine of x square plus 1. Suppose I may have like this, cosine of, let me write 2 raised to x. Now this is a composition of 2 functions. Which 2 functions? Cos and 2 raised to x. So I'll imagine this as x. So this look like cos x. What is the derivative of cos? You know, minus sine. We copy the inner function 2 raised to x into derivative of 2 raised to x. What's the derivative of 2 raised to x? 2 raised to x into log 2. So this is a final derivative of composite functions. I hope up to this you are clear with the chain rule. Chain rule is mainly for combination or composition of 2 or more functions. Next example, suppose I have root x. You know derivative of root x, 1 upon 2 root x. This is a standard function. But for example, I have root of, let's write cot x. So how I'll find the derivative? So we imagine this as x. So this looks like root x. What is derivative of root x? 1 upon 2 root x. But we are going to copy the same function cot x, remember. This is just same as this, considering this as x. What's the derivative of root x? 1 upon 2 root x into d by dx of which function? Cot. So into cot x. This is a chain rule, remember. Into always derivative of consider function as x. So into derivative of cot. So your final answer is What is derivative of cot? You know, minus cos x square. So minus cos x square upon 2 into root cot x. One more. You have derivative of 1 upon x. What's that? Minus 1 by x square. This is a very standard function. Suppose now I want to differentiate 1 upon let me write log x. So we imagine this like x. What is derivative of log x? Minus 1 upon x square. X means log x the whole square into, by chain rule, d by dx of log x, into, by chain rule, d by dx of log x, because you consider log x as x. Why 1 upon log x the whole square? In your mind this is x. What is the derivative of 1 upon x? Minus 1 by x square, remember, into derivative of this. So finally minus 1 upon log x the whole square as it is, into what is derivative of log x? 1 upon x, you know. So this is a final derivative of 1 upon log x. Suppose one more, I have you know, derivative of tan x, for example, which is sec square x. Now we did number of times. This is very standard function, right? For example, I have tan of 9x. So how we'll do this? We imagine this as x inner function. So this looks like tan x. What is the derivative of tan x, which is sec square? You are not going to write, you are going to x, you are going to write 9x only, into, by chain rule, derivative of 9x. What is that? That is just 9 here. This into 9 is because of derivative of 9x. This is what the chain rule. One more, suppose I want to do derivative of tan of sin x. Now we imagine this as x here. What is derivative of tan x? It is sec square sin x. You had imagined sin x as x. So into derivative of sine, what is that? Cos. So this way we use the chain rule. So next example is, I want to take this d by dx of e raised to 2x log of 4x. So you must have realized e raised to 2x is not standard function. Standard function means function that we have listed in that table, you know, in the first session. E raised to 2x log of 4x. 2 raised to 2 is just a constant. It is 4, remember. So here derivative will be 0. Let me see how we'll use here chain rule. So here d by dx of e raised to 2x plus d by dx of log of 4x plus d by dx of 2 raised to 2. Now what we do? We imagine this as x. What is derivative of e raised to x? E raised to x. So e raised to 2x into d by dx of, by chain rule, 2x. You consider this function as x, so derivative of this. Why e raised to 2x only? You know derivative of e raised to x is e raised to x. Plus we imagine this as x. What's the derivative of log x? 1 upon x. So 1 upon 4x into, by chain rule, d by dx of 4x. This is just constant, so here 0. So e raised to 2x. What is derivative of 2x? It is just 2. So I'll write here. Plus, what is the derivative of 4x? Is just 4. So 4 upon 4x. So final answer is 2 into e raised to 2x plus 1 upon x. One more, I'll use division rule. Like we want this d by dx of, let me write 2 raised to x square upon, let's write sine 3x. Now you see here both are composite functions. 2 raised to x square. You know derivative of 2 raised to x, which is 2 raised to x into log 2. So we imagine this as x. You know derivative of sine x. What is derivative of sine x? Which is cos x. So we imagine 3x as x here, right? And I'll use division rule. Now what is the division rule? You know, square the denominator function. So sine squared 3x. Now sine 3x as it is, d by dx of numerator function, that is 2 raised to x square, minus always now 2 raised to x square as it is, d by dx of which function? Sine 3x. I have just applied division rule, remember. Now we'll differentiate. Derivative will be now. So square as it is, sine 3x as it is here. We imagine you know derivative of 2 raised to x. So I'll consider these as x. What is derivative of 2 raised to x? 2 raised to x into log 2, you know, into derivative of x square. What is the, because this was your x, so what is the derivative of x square? It is 2x. So use the chain rule here, remember. Repeat this. You imagine this as x. What is the derivative of 2 raised to x? 2 raised to x into log 2 into, by chain rule, derivative of x square. What is that? 2x. Now we come to this, minus 2 raised to x square as it is here, differentiation of this. So we imagine this as x. What's the derivative of sine x, which is cos x? So cos 3x. 3x we are going to copy as it is, remember. You are not going to write x. We are just imagine that as x, into derivative of 3x by chain rule, which is 3. You know derivative of 3x is 3. So this is what differentiation by division as well as the chain rule. Now I may have like this. Suppose y equals to sine of tan of let's write root x. So there are how many functions? 3 functions, sine, tan and root. So we need to use chain rule twice. The question is here, find dy by dx. dy by dx means derivative of y with respect to x. So we are going to differentiate this. So how we'll do this? First we imagine this as x, because you know derivative of sine x. So let me do in the solution like this. I'll do in 2 different steps. So dy by dx equals to, I'll imagine this bracket as x. So derivative of sine x is cos, I'm copying that bracket, tan of root x, into, now derivative of this x, this is a chain rule, d by dx of tan root x. So you have used chain rule once. I repeat, you imagine this bracket as x. So taking this bracket as x. So what is this? This is sine x. What is the derivative of sine x? Cos x here. Into derivative of this tan of root x. So I have written as it is here. Now in the next step, this one as it is, remember here, we are not going to do anything because differentiation is done. Into, now like earlier questions, this is a new question for you. Imagine this as x. So what is the derivative of tan x? Sec square root x as it is, into now d by dx of root x. Again chain rule. Over here chain rule, over here chain rule. So cosine of tan root x into sec square root x into derivative of root x, which is 1 upon 2 root x. This is your final answer. Okay. One more. Suppose we may have like this. Let me write tan raised to log of, let's write tan x. Suppose this is a function, fx equals to this, tan to the power this. 3 functions, remember, tan raised to x, log and tan x. So how will do this? I'll imagine this as x. Now you recall what is the derivative of tan raised to x? It is tan raised to x into log tan. You know this. So here f dash x equals to, I'll imagine this as x. So tan raised to x means this only, remember, log of tan x into d by dx of that power function, which is log of tan x. Because this you had considered as x, so d by dx of this. So tan raised to log of tan x as it is, into, Now we imagine these are the x again, chain rule, this portion, sorry. So we imagine 10x as x. So what is the derivative of log x? 1 upon x. So 1 upon 10x into, again by chain rule, d by dx of 10x. And therefore, oh sorry, here derivative of 10x is 10 raised to x into log 10. I'm sorry, this I forgot to write. I repeat, I'll imagine here also, sorry, log 10 to the base e. Here, you know, you have considered these as x. So what is the derivative of 10 raised to x? That is 10 raised to x into log 10 into d by dx of this. So 10 raised to log 10 to the base 10 as it is. Let me write this. Log 10, this comes from the derivative, remember, of 10 raised to x, you know, here. Into 1 upon 10x as it is, and derivative of 10x is x square. So this is what the chain rule we have used twice. So ultimately, in chain rule, what we do is like this. If we have a function here, if we have function y equals to, let's write function u, and inside we have one more function v, for example. So there's a composition of two functions u and v. We want dy by dx here, that's the question. Here u is a function of u, y is a function of u is a function of v, and v is a function of x. So we do like this, dy by dx equals to first derivative of u with respect to v, so du by dv, into now derivative of v with respect to x, so dv by dx. So you see this, dv will get cancelled, so it is du by dx, which is exactly dy by dx. This is what called the chain rule. So this formula is not important for us. How to differentiate the composite functions, that is important for us. So now we go to exercise 5.2, which is based on chain rule only. Question number 1, first question. You are given this function sine of x square plus 5. Now you must have realized this is a composition of two functions. So in the solution directly you can start like this. D by dx, that means you are differentiating sine of x square plus 5. So we did now 9-10 examples, so you know, you imagine these are the x. So what is the derivative of sine x? Cos of x square plus 5 into d by dx of x square plus 5. So you have finally cos of x square plus 5 into differentiation of this, derivative of 5 is 0, x square is 2x. So this is your answer. Right? You have used the chain rule. You imagine this is x. There's a composition of two functions, sine and x squared, remember. So sine of this one as it is, derivative of sine is cos, into by chain rule derivative of this inner function, which is x squared plus 5. So this is your final answer. Let me go to second. There the function is cos of sine x. Okay. I can take this as fx also, whichever way you do. You can directly write d by dx also, it's up to you. Cos of sine x. Now I want to get the derivative of this, so therefore f dash x. You know now, derivative of outer function first. You imagine this as x. So what is the derivative of cos? Minus sine, this inner function as it is, sine x. You are imagining this as x, remember. So minus sine x into d by dx of inner function. What's the inner function here? Sine x. So we'll get the minus sine of sine x into derivative of sine, which is cos x. So this is your answer. This is f dash, remember, derivative. Okay. Let me go to fourth one. Third is the same question. There you have sec of tan of root x. You know now, as we did There is a composition of how many functions? 3 functions: sec, tan and root. So first we imagine these are the x. So let me write here d by dx. You are differentiating this, remember. This is equals to, first you consider this bracket as x. What's the derivative of sec x? Sec x into tan x. Sec x into tan x. So that bracket as it is, remember. Tan of root x into here tan of root x. You imagine that bracket as it is. Derivative of sec x is sec x into tan x. Now which one you had considered as x? This much. So by chain rule, don't forget this, d by dx of tan root x. I'll copy the first two terms as it is. Sec of tan of root x into tan of tan root x. We imagine, now we differentiate this. So we imagine this as x. Derivative of tan, what is that? Sec square, inner root as it is, into derivative of root x. Now directly I'm writing 1 upon 2 root x. So this is your final derivative, remember. I wrote directly derivative of tan sec square, derivative of root x 1 upon 2 root x. Here don't write like this. This is not correct. Sec square of 1 upon 2 root x. This is wrong, remember. It's not derivative of tan, that is sec square, and derivative of root x here 1 upon 2 root x. This is wrong, remember. You need to imagine this as x. So you say root x as it is, and here into derivative of root x, that is 1 upon 2 root x. Okay, next is this. Here you have product of two functions, remember. So we use product rule. So I'll call this as fx, cos of x cube into sine square x raised to 5. Now f dash x. So now we are differentiating. Product rule, you know what's a product rule. We keep, for example, this one as it is, derivative of this. So I'm writing product rule, cos of x cube as it is, d by dx of sine square x raised to 5, plus now this one as it is, sine square x raised to 5 as it is, into d by dx of cos x cube. What I did, I've used simply product rule. Now we are differentiating. So cos x cube as it is. How will differentiate this? Sine square is not the standard function. So what I'll do, I'll imagine this as x, remember. So this look like x square. It's look like x square, remember. What is derivative of x square? You know 2x. So this is 2 into this entire is x for us. Sine of x raised to 5. I repeat, remember here there are 3 functions, so we need to use chain rule twice. First square function, then sine function, and then x raised to 5. So here you imagine this as x. So this is x square. What is the derivative of x square? 2x. Now you come to sine. So for that you need to imagine this as x. So what is the derivative of sine? That is cos of x raised to 5. Now you come to x raised to 5. What is the derivative of x raised to 5? 5 into x raised to 4. So this much is differentiation of this portion. I repeat here, you imagine this as x. So this look like x square. What is derivative of x square? 2x into now derivative of this sine of this. So what's the derivative of sine of something? It is cos of something. And then derivative of that something means x raised to 5, which is 5x raised to 4. You have used chain rule twice here, remember. Now we come to this, plus this portion as it is, sine square x raised to 5, into, now we have just composition of two functions. We imagine this as x. What's the derivative of cos? Minus sine x cube into derivative of x cube, that is 3x square. Derivative of cos is minus sine, inner x cube as it is, derivative of x cube is 3x square. So differentiation is over here. If you want, you can simplify. For example, you can find here, out of these two, x square is common. One is this. Then sine of x raised to 5 also you can find common. So I'll find sine of x raised to 5 common. So inside the bracket, you are left with this 2 into 5, which is 10. X square we already taken common, so you are left with x square into cos of x cube, sine x raised to 5 already taken outside, cos of x raised to 5. This minus will be now here outside. Out of square, sine x raised to 5 already taken common, so this is sine of x raised to 5 into sine x cube. X square you already taken outside, so you are left with just 3 here. So 3 into this. This is a final derivative. This is not important step, this is just algebra. Up to this, differentiation is important. Remember, this is f dash x. This was fx, remember. Here product and chain, both rule are used. Okay. Now here in this question, we have division rule. So I'll use division rule here. Square of denominator function, that is cos square cx plus d. Now cos of cx plus d as it is here. Differentiation of numerator function, d by dx of sine of ax plus b. Minus here sine of ax plus b as it is into d by dx of cosine of cx plus d. This is what the division rule, you know this much. Okay, now I'll do differentiation. There we need to use the chain rule. Cos square cx plus d as it is. Here cosine of cx plus d as it is. Here when we differentiate, we need to imagine these are the x. What is derivative of sine? Which is cos ax plus b. By chain rule, derivative of ax plus b, derivative of b being constant 0, derivative of ax plus b is just a, because derivative of x with respect to x is 1. So here you have into a. I repeat this, derivative of sine of ax plus b. We imagine this bracket as x. What is the derivative of sine cos? We copy this bracket. By chain rule, derivative of ax plus b. Derivative of b is 0. What's the derivative of ax? It is just a. Minus, now sine ax plus b as it is. We come to this. We imagine again these are the x. What's the derivative of cos? Minus sine. So I'll put here plus. Sine cx plus d into, now by chain rule, derivative of this, which is derivative of d0 being constant alone, c constant with the function. So derivative of x is 1, c remains same. So into c. This is the differentiation. This is your answer. Next function is d by dx of 2 into root of cot of x square. Now 2 is constant, so 2 remain as it is, remember, if you are constant with the function. So differentiation of this. Now as we discussed earlier, we imagine this as x. Recall what is the derivative of root x? You know it is 1 upon 2 root x. This much you know. I'll imagine this as x. So 1 upon 2 root x. X means cot of x square, remember. By chain rule, d by dx of cot of x square. You imagine this as x. 2 being constant as it is with the function. If 2 alone, then derivative is 0, but here it is with the function. What is derivative of root x? 1 upon 2 root x into derivative of this cot of this. Okay, so this 2 will get cancelled. Here we are through, so I'll copy just cot of x square Now we come to this. Here also your composition of two functions. We imagine x square as x. What's the derivative of cot? You know, minus cos x square of x square as it is into here derivative of x square, which is 2x. You had considered x square as x, so into derivative of x square, which is 2x. So minus cos x square of x square into 2x upon root of cot x square. This is your final differentiation. I had started with d by dx, remember, so this is the derivative. The last eighth one, you need d by dx of cosine of root x, which is too simple now for you. Imagine this as x. What's the derivative of cos? Minus sine of root x as it is, and by chain rule derivative of root x, which is 1 upon 2 root x. Okay. Ninth and question number 9 and 10 we already discussed in the earlier session. These two questions were discussed.